Hello, everyone, and welcome to the Hedera Technical Community Call. I'm your host, Ed Marquez, leading the developer relations team for the Hedera ecosystem at Hashgraph. And today we have a great set of topics lined up for you. But before we get into that, I do want to do a little bit of housekeeping. The first item is remember that this call is being streamed and recorded. So it's being streamed to multiple channels, LinkedIn, X, YouTube, and more. So you can share them with your network so that they can stay up to date on the technical developments and interesting topics happening in the Hedera ecosystem. And it's also being recorded so that you can go back, watch a specific segment or the whole thing later, and also share it after the fact. We also have a bounty right now on X402. You can think of that as a mini hackathon that is accessible with this QR code that you can see on the screen. So if you want to go check that out, scan that QR code and start building towards that bounty. Now, it's something that we're going to reference multiple times throughout this call, and then we're going to get deep or go deep into X402, which is today's topic. At least two of the three segments are on X402. So remember, scan that QR code and stay attentive to the additional details and information that are going to come throughout the call. So with housekeeping out of the way, I do want to welcome our guest speakers to the stage. So Ty and Narbeh, please. Excellent. So Narbeh, let's start with you. If you could give us a quick introduction of who you are, what you do, and maybe the topic that you'll be covering, just to give that teaser to the audience.
Certainly. Thank you, Ed. Yes. So my name is Narbeh Shahnazarian. I go by Narbeh for short. I'm a solutions architect here at Hashgraph. I've been here, I think, about 2 months, maybe 2 months and some change, working on the AI studio team. So think about things like the agent kit. We were involved in the AI hackathon that happened about I think it just wrapped up a couple weeks ago. Prior to joining Hashgraph, I worked at a decentralized infrastructure network called Lilypad. Prior to Lilypad, I had worked as a full stack engineer essentially at Expedia for about seven years, working all throughout the shopping stack there, back end, checkout, front end. And in between, I also do these streams every week. I host a podcast called Dev and Tell, the Developer DAO, allowing founders, hackers, and anyone in between the opportunity to showcase what they built. So I feel right at home here on the stream. Yeah, pleasure to see everyone on the stream, and I'm really excited for today's topic on X402 and some goodies beyond that as well. I will be showcasing some APOC kind of around Hedera and how X402 can play together. So excited to share that with
Yeah.
y'all.
I'm very much looking forward to your topic, and glad that you could join us here, not only in the Hedera ecosystem, but in today's call covering this topic. So thank you, Narbeh. Next, I do want to give the mic to a veteran that many of you may be familiar with, veteran to the Hedera ecosystem and also Hashgraph. So Ty, please tell us who you are, what you do, and just do a reminder of the topic that you'll cover.
Yeah. So I'm excuse me. I'm Ty, also known as Patches in the ecosystem. Been building on Hedera since 21, so been around a lot. And I am a senior product manager of the token service, and I help with some AI strategy stuff, the consensus service, to sort of jack all trades. So really enjoying this talk. I'm excited to see what Narbeh's going to be showing everybody. And then personally, I'm going to be going over a little bit dry material, but it's sort of that necessary housekeeping of account balance query. And just going over the deprecation of that query, what you should be planning on if you're a developer utilizing that, and then what is coming up in the future for a replacement for the query that's going to be deprecated. But I'll get into that a lot more in my presentation.
Awesome. Well, with those intros in mind, I think it's a good segue for you to take the stage, take the mic, and let's dive deep into your topic, Ty.
Sounds great. Awesome. So account balance query. This is a query inside of the SDK, And we're just going to go over the deprecation of it, what is changing, why is it changing, how builders should migrate on the Hedera SDK for balance over to the mirror node. So it's an infrastructure routing change, not a loss of balance visibility. So we're not losing anything, but the balance access remains available. The query path just changes. Right now, you can do an account balance query in the SDK. That's going to be deprecated, and I'll go over the timeline in a little bit. And then mirror nodes, where you should be getting the information off of information off of the network, will be where you should get the balances. So production reads from mirror nodes and REST APIs is the recommendation for the changing of account balance query in the SDK to REST API to the mirror node. Biggest takeaway, biggest reason, when you do an account balance query through an SDK, that actually does hit a consensus node. Consensus nodes really want to put most, if not all, of their energy into consensus. And so reading all of these queries and this traffic is not the alignment that we're looking for. And mirror nodes are made for data access. So balances, dashboards, wallets, analytics, monitoring, all of that is really made for mirror nodes. So that is where this deprecation is coming from and where the next stage of where to get balances should go. So today, sort of little went over this, but the application, the SDK, will call a consensus node, and that will read its local state, and then it will report the balance response from that state. So the SDK query sends a balance request, and the query or the consensus node is answering, which is, again, not the happy path that we're looking for. So right now, we are doing a throttle step down. So we're not just turning off the ability to do an account balance query. We have put a bunch of notices out previously. We have a blog that goes over a lot of this content that we'll share again. That talks about how we are downgrading or throttling down this query. So right now we're at 40,000 requests per second. When 75 comes out this month, it's going to be halved down to 20,000 requests per second. So what that means is when there's more than 20,000 requests per second, the 20,001st request is going to get a busy signal. And so slowly taking down the amount of queries that the consensus nodes have to be prepared to answer. And then in August, on the 76 release, when that comes out, we'll be down to 10,000 requests per second. And then in September on version 77, it will all just throttle to zero, and this query will no longer return valid balances. And everyone should really be planning on migration off of this if you're still utilizing it over into the mirror nodes, especially before the September deadline. So again, why is this happening? Just high volume balance reads place avoidable load on the consensus nodes. They're optimized for transaction validation and consensus of other nodes. And the direct read traffic, just as the network continues to grow in usage, isn't the correct place where that should be going. So the target state, consensus nodes on consensus, makes sense. Mirror nodes are on serving balances, transactions, tokens, topics, analytics, monitoring. And then in the future, we have block nodes and block streaming, and that's planned to support event-driven access patterns with a lot of extra things in block streams, which would allow state proofs of those blocks. So there is a new thing coming with the block nodes that will have new queryable information as well. So right now, mirror nodes are ready. You can be hitting a mirror node for a balance just by this GET request to this API route. It's production ready, it's scalable, it reads, and it, again, lowers that consensus impact for the scalability of the network to continue. So today, account balance query, this is sort of what it looks like. Tomorrow / before September, definitely, you can do the same. You can do a different one with just a fetch onto the mirror node, the mainnet mirror node, and getting the account ID, and then parsing the data from there. So when you're using mirror nodes, for small default app reads, the REST API, the public mirror node is absolutely a good target. You can easily get balances tokens from the public mirror node, as I showed in this example, mainnet.mirrornode.hedera. But when you have higher volume, when you have production applications, when your development requires good data then you should look for a commercial mirror node provider. There's several in the ecosystem that have great plans for you, and especially if you're building a dApp, you need to make sure that you're not just relying on the public mirror node, but a commercial mirror node provider that can give you a lot more scale and validity and scale, making sure that you don't have any downtime. And then the future path, we will have block nodes and block streams, and it'll be another way to get information off of the network in a new way with some proofs. So recommended migration list. First, just audit your code. Just look, is account balance query there? Look for the wrappers .get account balance function. If it is there, then just replace and move that balance read with a mirror node REST endpoint. Make sure you harden, test, retry, caching, throttling. Make sure that everything is working, validate it, and then make sure you deploy before version 77 hits the network of Hedera in September. So that was it, a little quick, but definitely really important. Make sure that you're using the best way to get data into your application so that it works, and it works very well. So audit usage, migrate your read, ship before 77, keep it that simple. And yeah, I appreciate the time listening to my presentation.
Ed, I think you're on mute.
Yeah, I can't hear Ed. I thought it was me.
Yes, I think it was a hardware issue there with the mic. So I think we're back. Thank you, guys. And thank you, Ty, for that overview. So we'll give a minute for the audience to ask any questions in the chat. But one question that I want to ask, Ty, is what differences could developers expect perhaps around latency or response time when going and following this migration path from the SDK query to the mirror node?
Yes, so the SDK query did get the consensus a little bit faster. The mirror node's probably a 3 to 5 second lag time of once you submit the transaction. So just make sure that you're adapting any code that expects it at a certain time interval to make sure that you're waiting at least 5 seconds, or you're at least checking. If you check in 2 seconds and it's not there, you check another 2 seconds. But yeah, add some flexible understanding, because it can be, you should never hard code how many seconds it's going to take for anything coming back from the network or from any network or any computing network. So yeah, look and check. And if you don't get a response yet, but you'd expect one, just have redundancies of where your code is going to hit that mirror node REST API one more time in a couple seconds, and then you should be absolutely fine.
Makes a lot of sense. All right, so it sounds like the impact might be going from 2 to 3 seconds to maybe 5 to 6 seconds in terms of a difference.
Yes, and that's as good as you can get. It's definitely not a hard number, just because of the fluctuation of how much, what's the TPS and everything. But yeah, that's a good kind of estimation of what you should expect.
Excellent. All right, so thank you again, Ty. I think at this time we'll move on to the second segment, which I'll be covering, and that's going to be focusing on the fundamentals of x402. So let's go ahead and start the screen share right now. And I want to start with picturing a scenario that perhaps many of us have been on or been in, which is you have an AI agent, you give it a real job, right? And the real job is, say, research 5 suppliers, compare their pricing, and then come back to me with a recommendation. It's doing great, but then on that third website that it's researching, it actually hits a wall. And the issue is that the problem or the number that it needs is behind a paywall. Imagine it has to, pay $4 to get the information, then your agent freezes, and it cannot pull a credit card, a bank account, or it cannot click subscribe, right? And that's when you realize that every system that we've built to take payments on the web assumes that you have a human or a person sitting on the other side. And the moment that software tries to pay autonomously, the whole thing kind of breaks apart. And so the strange thing and the interesting part is that the web saw this coming about 30 years ago, because in the HTTP spec, right next to that 404 code that we see every day on a broken website, there's also status code that has never been used up until recently, right? And that's 402, payment required. Because the people that wrote the standard back in the day also noticed a few words, or added a few words next to it that said reserved for future use. And so they left that door open for the web to accept payments. And then for 30 years, this has been closed. That door has been closed because no one needed it. But that just changed with AI agents entering the picture, right? And so that agent that is stuck can probably benefit from this type of technology. And so, yeah, I just want to do this little overview on how we can teach the web to pay or to let agents pay. In terms of a little bit of background, I mentioned I lead developer relations for the Hedera ecosystem. I come from an mechanical engineering background. I've worked in automotive. I've done system models and control systems in the past. More recently, in the past 5 to 6 years, focused on blockchain and also exploring that overlap with AI. And so with that context in mind, what I want to get out of this session is that by the end, you'll know why the human payment rails fail for agents, how this protocol called x402 can help us fix that, and then how you can start using the protocol. And so let's start by looking at the challenge. And to understand the challenge, we also need to understand what is agentic commerce. And it's just when you have machines acting as autonomous economic agents, right? So that means that they can intermediate and execute deals, whether it's on behalf of a human, an organization, or another machine. And of course, it's going to be a spectrum. I think many of us are familiar with that first box where AI is suggesting, doing a recommendation, but you as the human retain the decision-making power and the ability to pay. And then further down the spectrum, you also have something that we're seeing more of, which is agents being delegated to execute a deal within a strict set of policies or rules that the human sets. And then, of course, the third box is where we see things going, which is fully autonomous agentic commerce. No human in the loop, and the agents can negotiate or execute the deal autonomously, right? And the agent has that ability to make micropayments for the API that it needs, or maybe it just buys and sells in a marketplace. Now, it's not just me saying that, right? We also have analysts like Gartner and folks like the Linux Foundation seeing this. And in fact, Gartner thinks that 90% of business-to-business or B2B purchases are going to be intermediated by agents. And so that's an opportunity of over $15 trillion by 2028. Now, that's a forecast. Here's the measured number that we have today with the x402 protocol. And it has around 69,000 agents that have run almost 200 million payments. And in terms of volume, that's roughly $50 million in volume, so about $28,000 a day. So it's not extremely high. We have the rails, they are here, but the volume is not super high just yet, right? And that gap between the $15 trillion and the $28,000 a day, I think that's the opportunity that we have in the next few years. So let's see where things actually are now, right? Because here's what's happened in about 12 months back in 2025. So in April of last year, you had players like MasterCard and Visa. They both announced agent payment programs. So you had Agent Pay and Intelligent Commerce, from each one of those players. Then in May 2025, that's where we had Coinbase ship x402, and that's what we're going to spend most of our time on for the rest of the session. And the ability there, or the new element there, was the ability to pay over HTTP. And then in September, you also had other players like Google publishing an agent payment protocol, AP2. And that was done in collaboration with over 60 partners. And then you also had OpenAI shipping another one with Stripe called ACP. And the key point there is you have 4 parties, right, between the credit card networks, the AI labs, the cloud platforms, and crypto. 4 parties that agree on almost nothing, but they're all building the same thing, which is a way for software to pay. And so when everybody who moves money is moving in the same direction, I think that's certainly a telling sign. All right. And so if agents are going to buy things and pay for things, the obvious question is, how do they pay? And we have a few answers that we would try first, right? Like maybe we just give them a bank account or a credit card or put it on a subscription. But the thing is, we have to look at each one of those because they break in different ways that we can learn something from. So if we go with the first option, we just give it some money, right? We give it some direct financial access. I mean, what could go wrong? The interesting thing is we already did that experiment. By we, I mean Anthropic. They had this experiment called Project Vend. And in 2025, Anthropic let Claude, an instance of Claude, they called it Claudius, and they enabled it to run an office, a small office store autonomously. So they gave it real money, real inventory, control over the prices. And the interesting thing is that it did not go so well, right? So this graph is direct from their article. And the issue, or the set of issues, is that Claudius actually got talked into giving discounts and giving products for free by its colleagues. It also did the opposite, right? So it tried to charge money for things that were supposed to be free. And it couldn't handle sarcasm or jokes because in one instance it became obsessed with ordering tungsten cubes after a colleague made a joke request. So it was quite interesting. And it was even hallucinating accounts, for customers to send payments to. So not a very good scenario if that's something that you're trying to give direct money and financial access to. So Anthropic's conclusion is we would not hire Claudius, right? And so that's the same thing that we're talking about giving a bank account to. Now, all right, let's not give it a bank account. Let's explore option 2. What if we just give it a credit card? And so, if you drop the credit card number in the agent's context and let it check out, you have 2 problems. The first one is you have no ceiling, right? No spending ceiling. And so you're just like one bad loop away from overspending. And in most cases, there are no hard policies or nothing structural to stop it. The second problem is you have prompt injection. And that's something that researchers, and I think we all have seen this in the wild. And so you could have a malicious web page that when the agent visits, it can hide instructions that maybe quietly add items to the cart or instructions to maximize spending on that site. And the cart would have no idea that those instructions are coming from a malicious website. Now, here's the tell, right? Because we also have to watch what players like Visa and MasterCard are building. And their answer to give the agent a card is not a regular credit card. They're coming up with tokenized credentials that are locked to a single agent, to a single merchant, and one spending limit. And so when both of these networks are building a new primitive, that's how you can tell that the regular credit card is not the right answer for a large language model. And then moving on to option 3, say we just charge a flat monthly subscription, right? But that breaks too because agents don't consume like people. They're going to fire thousands or hundreds of calls and requests in an hour, and then maybe nothing for days or weeks. And so having a flat fee just fundamentally misprices that, right? And that's why we're seeing many industries already drifting towards having fee or usage-based fee and billing, right? As opposed to just a monthly flat fee. And I think that makes a lot of sense because the natural unit for machine consumption is not a $20 subscription or a monthly seat, but it's per request. And so that's, I think, what's driving that that shift there. And so each one of those payment options fail for various reasons, right? One is the fee floor. If you look at a standard credit card and typical banking charge is about 3% plus 30 cents. So if you're trying to make an API call that costs 1 cent or a fraction of a cent, you have a fee that is bigger than the thing that you're actually trying to pay for. So the human rails don't necessarily make sense for that. The human rails were built for a $40 transaction or a $400 transaction, but not for a fraction of a cent. You also have the identity issue, right? A bank account requires KYC, a legal person, a tax ID, a signature, and an agent cannot provide most of those things, right? And so, fortunately, when you have a wallet, that's just a key pair. And so there's no gatekeeper, not necessarily KYC. And it also works on a Sunday at 3 a.m. So the agent cannot get a bank account, but it can indeed hold a wallet. And then the third one is interesting because we've tried micropayments in the past, but there's a study or an exercise done by this guy, Nick Szabo, where he realized that it wasn't necessarily technology the limiting factor, it was us, right? There's a mental cost if we had to evaluate how much an item is actually worth and how much I'm willing to pay for it, right? And so if we have to do that 10 times, 100 times, like there's a mental barrier there that doesn't apply to machines. There's a mental transaction cost that doesn't apply to machines. And so, these reasons actually raise an interesting question, because if we need to build a payment rail specific for agents, what would it have to guarantee? And so we're going to explore that question. Fortunately, it already exists, so you don't have to build it. It's x402 on Hedera. And x402 is an open standard, right? A protocol that came up in 2025, as we saw, and it finally wires up that status code for x402 that was unused so that agents can pay over HTTP. So let's go over this first, and then we'll come back to the question about the guarantees. So diving deep into the pieces of the standard, it relies on 5 key pieces, right? You have the client, that's your agent, and it can hold a wallet and a key pair that it can sign with. You also have the resource server, so that's the thing with the API or the content that you want, the thing behind the paywall. You also have a facilitator. This is a new piece of infrastructure, or maybe the one that most of us haven't heard about. And it's almost in a way that the hero of the story, because it's a service that checks the validity of the payment, and it also settles the payment on the blockchain. That way the resource server doesn't have to touch a blockchain. And then you also have the settlement layer. So that's your distributed ledger, where the value is going to move. So that's Hedera and other networks. And then you also have the stablecoin. That's going to be the unit of account, something like USDC or a digital or tokenized dollar. It can also be, in some cases, the native token of a network, for example, HBAR on Hedera. And so in the simplest terms, I want you to think about x402 or this protocol as one request, one rejection with a menu, and then a retry with a payment authorization. So looking at the more detailed sequence, what you have is it all starts with your agent making a regular request, right? Like get premium data. There's no payment in it. Your client just asks, but then the server gives the response, right? It says, no, I actually need you to pay for this. And here are a few machine readable options. For example, how much to pay, in what token, on what network, and to which address. And then the agent is going to read that menu. It's going to, pick some options, and it signs a payment authorization. That happens off chain. It's just a signature. There's no transaction or gas involved just yet. Then the request is sent again, but this time with a header called payment signature. And the server is going to hand that signature to the facilitator, right? So it's going to ask the first thing, which is, hey, is this valid? So that's the verify call. And then once that's verified, the server does the work, and then it calls the facilitator again to settle it. So that's the settle call that you see there. And then once that's settled, the facilitator pushes that transfer on chain, and the facilitator is the one that pays the gas, right? So finally, once that's successful, the server gets back a transaction hash or a transaction confirmation, serves your data, and includes a receipt proving that payment. So that's the sequence, right? And what you see here is that the entire process is just HTTP plus that one signature off chain. And then the blockchain is only touched at the very end on that purple line, or that purple arrow that you see at the very end. And that's how that agent that was stuck in the beginning behind that paywall can actually pay for a few cents or a few dollars and get the answer that it was looking for. Now, I do want to zoom in into a few portions of this sequence diagram. The first one is, let's see how that payment payload can be created, right? And then we'll also look at those post calls that you see there. So for creating the payment payload, the agent doesn't actually send a blockchain transaction. It just signs a message off chain that says, I, the agent, I authorize this much USDC to this seller, valid for the next few minutes, and maybe only once, right? So that the payment doesn't get reused over and over. So that's the JSON that you see there on the screen. And the mechanism is quite important too, right? It's called transfer with authorization. So that's what enables the agent so that it doesn't have to worry about having the native token or the gas in its wallet. It's just, having digital dollars to pay is sufficient. And then the blockchain is only touched once, as I said. It's going to be touched by the facilitator when it triggers that payment in the after the settle call. And so, yeah, that's the whole process. You have one HTTP, one signature, and the movement of the digital dollars. Now, let's also take a look at the post requests that the facilitator does, because it's doing some interesting bits, right? And you probably noticed in the sequence diagram that the resource server does not touch the blockchain, right? If you look at those lines there. So it just checks a header and it makes 2 request calls, and then it serves the content. That's what the server is doing. So looking at what the facilitator does, the verify call actually checks, is this signed payment good for what I'm charging? And then the settle call, it just says, facilitator, push this on chain and give me that transaction hash. So that's the whole integration for the server. Again, no need to deal with private keys, touch a blockchain or anything like that. And so looking at the trust part is very interesting, because I'm sure many of you are asking questions, right? So the trust part is relevant here because you're not trusting the facilitator to hold funds. You're only trusting for availability of the service. And so the facilitator never holds your money. It's non-custodial. And, the amount that the recipient actually gets, it's all baked into that signature window, right? So the facilitator cannot change the things that are in the payment signature. It cannot inflate the charge. It cannot redirect the funds. It can only, stall or not serve or refuse to serve the request. It cannot steal. And so you're trusting for the liveness of the service, not for the custody of the funds. All right. So now that we understand the key pieces, what does it actually look for you, right? If you're someone who's trying to sell an API to someone, or you want to enable an agent to buy with this tool. So if you're the provider, right, charging for an endpoint, you just add this payment middleware from the package. You point it at a receive address. You set the price as a dollar string, like maybe 10 cents or a fraction of a cent. And then you also specify other things like the network for the payments and the scheme that you want to use, whether it's exact or up to or a few others, if you look at the X402 spec. And then on the consumer side, if you're paying, you simply wrap your HTTP client, you give it a signer or its wallet, and then you can just call the URL as you normally would. And then, the 402, the signing, the retry, all of that is going to happen automatically under the hood with these few lines. So yeah, that's the whole deal. One side sets the price, the other side just wraps a fetch, and neither one has to worry about a blockchain node. All right. That also means that the protocol is chain agnostic. And so each chain actually plugs in how it signs, how it settles the payment. And broadly speaking, right, you have, the EVM chains, you have non-EVM chains. And so on the EVM side, in chains like Hedera, we use transfer with authorization. So that's pretty much a standard that makes things quite easy. On the other bucket of non-EVM chains, those chains might do signatures slightly different and other things, but overall the flow and the sequence diagram that we saw is pretty much the same. One interesting thing here is that now you have these catalogs like Bazaar that are popping up to help your agents discover where they can pay for X402. And so these marketplaces and indexes are certainly something, a helpful tool for agents to discover. All right. So coming back to that question of what does the settlement layer actually have to guarantee for agents? And I would say it's 4 things. The first one is obviously sub-cent predictable fees, right? Because if the fee is larger than the thing that you're trying to pay for, the model kind of dies. You also need fast finality. And so, the agent and the server have to know that the money is truly settled before they hand over the resource and the payment in a single HTTP cycle. So having a chain where, it's maybe confirmed is not good enough here. And then you also want to have, a protocol that is neutral and open. As I mentioned, x402 is open, so any agent can pay and use it without permission. And I think you want a similar approach in the rails underneath the use case, because it's going to have implications on governance, and also the fees are going to have an impact on what you're trying to buy and sell. And then, of course, you want a tamper-evident record, because nobody's watching these exchanges happen in real time. But if you have a verifiable receipt trail that you can then reconcile and audit if necessary, that's a huge value add. And so I would say that, on Hedera, x402 it's a perfect fit, right? Because Hedera, you have the fixed fees, and then those fees are not going to vary with congestion. They're also predictable and sub-cent, whether you're trying to pay with HBAR or with USDC. You have very low costs to transact. You also have finality with the highest possible degree of fault tolerance in a distributed system. That's aBFT, or asynchronous Byzantine fault tolerance, and finality that happens in about 3 seconds. A little more if you're trying to propagate the information to the mirror nodes, as Ty shared earlier. And then you have a protocol that is also neutral and open. So the code base lives under the Linux Foundation. There's no single vendor that owns it. And then there's also a way to create tamper-resistant records with this ordering service that is the consensus service that gives you that timestamped, cryptographically verifiable log for your agent activity. So Hedera is a clear home for agentic payments and also commerce with x402. Now let's see how you can start using this. So this is the third leg of my presentation here. And I want to start with taking a look at who's actually using this, right? And I think CoinGecko is a name that many of us are familiar with. It's a market data company. And now they will sell your agent a single API call for about $0.01 in USDC. So you don't need an API key. You don't need a subscription. You don't need to sign up. The agent just asks, it pays, and it gets the price feed that it needs. And then we also see players like Cloudflare also returning 402 to AI crawlers. And they're opening a gateway, right, to be able to charge for any page or any data set or any API in stablecoins. And also players like Stripe and Google starting to wire 402 payments into their payment stack. There's many more, but just this goes to show that, you have players in the financial space, in Web2, in cloud and payments, trying to jump on this and adopt it. Now, you can do very interesting things too. If you're an individual developer, you can start selling API endpoints. I saw this interesting article about this one guy that shipped, 180 plus endpoints in a single weekend, and now he's monetizing that. Now, if you're an enterprise developer, you could also consider metered pay-as-you-go billing for your solution, right? We see many industries already going in this direction with meter billing, but the payment settlement is still on old human or traditional human rails that are not going to be agent friendly. And if you're building agents, you could, publish something like a skill or create something similar and sell it to other agents. And hopefully we would love to see you do that on Hedera. Now, the last thing is I want to show you this landscape of standards and protocols, because x402 is just one layer, is the money layer, right? And around that, you have this whole other stack that is being developed and snapping into place. And all these standards don't necessarily compete. They just tackle different concerns or different aspects. So x402 is not trying to be everything, right? It's just that payment primitive that other things can plug into for commerce, for communication, maybe for settlement, identity, legal concerns, and other things. And so I would say this slide is a good homework for the weekend if you want to dive into some of these other protocols. Absolutely continue your research and learning with this. All right, so now that we've gone through all these sections, I do want to leave you with some actions you can take today before we go into Narb's session. I want to bring again that bounty that I talked about for x402. So you can register scanning this or simply going to hedera.com/x402. And there you're going to see the requirements, the key information, the timeline for the bounty. So you have until July 31st to build and submit your solution. using x402 on Hedera. There are these resources and links that we'll make available also via comments in the description of the recording and so on. So you can check out the documentation and some GitHub repositories to help you get started getting your hands dirty with x402 on Hedera. And so just to summarize the session here, we saw that agents are becoming real economic actors, right? And the payment rails that have been for humans break when software is trying to pay. We also saw that x402 is this protocol that switches that 402 status payment that has been unused for decades into something that can make money move, whether it's micropayments or fractions of a cent. It works pretty well. And you can start building on it today, whether you want to do paid endpoints for an API or meter consumption, or maybe you want to enable your agent to pay other agents and websites. That's something that you could build with x402 on Hedera. And we saw also all the benefits and how Hedera is a great match to use x402 and agentic payments on the network. So HTTP 402 waited for 30 years for a user, and that user is finally arrived, right? So if you remember that agent that was stuck at the very start, now it's not stuck anymore, right? When it hits the paywall, gets a 402, it simply pays. It's $4 or whatever, or micro payment, and it gets back to work, right? So that door that was closed for 30 years is finally open, and we can let the web enable agents to pay. So that's what I have here. And if there are any questions, comments, please feel free to share them in the comments, and we'll be happy to tackle those. One of the resources that I showed was also this proof of concept where you can pay for inference, which is exactly what Narbeh is going to tell us more about in the next segment. But yeah, Ty, Narbeh, any comments or questions?
No, I thought that was quite the comprehensive overview. That was great. Well done.
Yeah, amazing.
Yeah, that's it's probably one of the hardest things to do is to understand where everything lies in the AI industry at any moment, because as you made that slide, I'm sure 3 new protocols were created. So I think it's a really good map for today, and then just always stay up on top of it, because like in 2 weeks, I'm sure there's just going to be more. So yeah, that was a great presentation.
That's spot on, Ty. As I was developing this presentation, new protocols came in, and I had to go and update that slide about the protocol. So spot on. We have a question, and Narb, I'll call you here for help. So which other networks have x402? I know it's on Base, Solana, and a few others, but if you could give us a more comprehensive overview.
Off the top of my head, of course, Hedera, and then I know Aptos has it. I think Sway has it, Stellar, and a few others that I can't recall at this point in time. But if you go to the x402 org and you go look at the protocol and the schemas that are there, it'll list all of those. Another way to do it, you can hit up a x402 facilitator and do /supported, which will give you back a JSON object of all the supported networks that facilitator supports.
Awesome. All right. I know we do have a few questions. We'll be answering those async, but now, Narb, I want to give you the stage and the mic to go over the POC that you have for us.
Amazing. I'll try to I'll try to do my best to follow up on both yours and Ty's presentations. All right. Yes. So I'm ecstatic to kind of share a proof of concept that I built, kind of inspired by my curiosity in the space itself, and to complement Ed's material from what you learned. So. Yeah, so the motivation, as Ed mentioned in his slides, there's a growing interest and bigger volumes of transactions that are happening by both agents and humans. About 52 million from what I saw. So you see, things do change from slide creation to slide creation. According to agentic.market, which is Coinbase's agent market. And I think the reason why the volumes are higher here, in comparison to some other protocols is because x402 had that real early mover advantage over things like machine payments protocol and AP2, but those are now growing and kind of taking some market share as well. Most of these things like x402 and MPP, they fulfill the same purpose. They work with the 402 protocol. They just work kind of differently at the protocol level, but they achieve the same end goal. So my motivation for this proof of concept was to explore the state of x402 on Hedera. As I mentioned, I'm 2 months fresh to the Hedera ecosystem, so just wanted to see where the lay of the land is. And this particular proof of concept is around using x402 to pay per request for inference. And what piqued my interest and got me excited for this is another project, a deep end project called Venice.ai, run by Eric Voorhees. And the premise behind that is kind of inference with privacy in mind. But one of the things that Venice supports is purchasing inference with x402. Today is supported by, I think, Base and Solana, but we're hopeful that we can also get Hedera in that game as well as getting Hedera on other marketplaces supporting x402. So this, like I mentioned, this proof of concept is paying for inference, and it will demonstrate how to do that. We'll be able to pay in both HBAR and USDC on both testnet and mainnet. So yes, we'll be spending some real money, so to speak. Underneath, we're going to be using two facilitators. One is run by a group called Blocky Devs, where their facilitator is the Blocky 402 facilitator. So they support both testnet and mainnet. And the x402.org facilitator for testnet itself. And for this inference, to kind of play within the lines and not break any terms of services with any other API providers that I might be using, this inference will be running locally on my machine via LM Studio just for demonstration purposes, but you can switch that out to whatever you'd like when you are playing around with this code. So this is a architecture overview. This is a technical call, so hopefully the sequence diagram is appreciated. So in a nutshell, there's kind of let's say there's five components to the actual POC itself. So we have a simple chat UI, which sits on top of two services. One is the agent server. So this is the thing that kind of initiates or talks to the front end to be able to request for inference. And then we have an inference service, which is basically a proxy, a light proxy over the inference service, in this case, LM Studio, as well as a touch point to the facilitator. So kind of going through the flow here, a user comes into the chat UI, types a message that hits a route API chat, which hits our agent server. Our agent server routes that request to our inference service. Our inference service comes back with a 402 challenge asking for payment for said inference. And then our agent service creates a response to that challenge, paying a request or asking for or requesting for that inference in the payment method of choice, either HBAR or USDC in this case. It sends that payment signature to the inference service. The inference service sends that request to the facilitator, and it hits the verify endpoint and comes back with a receipt. So that is that's a gasless transaction. Nothing really happens on chain there. It's just more of a verification, like Ed mentioned in his slides. And then once that receipt is accepted, we go and we hit the actual chat completions which actually runs the inference. Once that comes back, so the work is done by the inference service itself, then we settle and send the payment with the settle endpoint. So to see that in action, I have a video here. I'll kind of walk you through it. So this is the simple UI. So we're going to start with testnet, paying with USDC. I'm going to ask it to write me a haiku about micropayments. So right now, what happened is we sent the transaction, we did the verify, and now the model is running, doing its work. So this inference is running locally. So we got back a response, and we actually paid a fraction of a penny on USDC. So I'm going to do another one. I'm going to ask it to write about blockchains now. So same thing. We sent sent a verification. Now the model is running, and we settled. So we paid 0.02 USDC. And looking at the block explorer, we see both these transactions indeed did occur on chain. So now we'll go back, and now we'll try mainnet. We'll spend some real money here. So I'm going to do mainnet and hbar just to change it up. And again, so now we're going to ask it to write some Python. I'm going to ask it to explain quicksort to me. So again, we submit the verification. Now the model is running. It's doing its thing. And once it completes here, so we get the response. And we settled with paying hbar on mainnet. So once we go down here and click the hash scan link, we'll see on mainnet, if we click the transactions here, that we indeed did pay 0.01 hbar for that inference. So that was the demonstration in a nutshell. Please, I encourage you to visit the POC repo, download it for yourself, get it working at the very least on testnet, so you can have something to play with. Go modify it, go change the resource server to whatever your heart desires. But I am really excited for the potential for x402 and some of these other protocols as well. This just proves that Hedera is indeed ready to enter this space, and I'm excited to see what all you builders start to build with us. And I believe, are there any questions that we can take from the crowd?
Hey, Narb, that was awesome. So let me come back to the stage here along with Ty. Excellent. There are some questions. Thank you so much for that awesome overview. Let's start with the first one coming in from Suri. And the question is, what do you see as the biggest challenge to making autonomous agent-to-agent payments work at scale? Is it identity, trust, or payment infrastructure, or something else?
I think it's a combination of the three, and Ty, also keen to hear your thoughts as well. But I think the space is still very, very new. The concept of machines paying for things, I don't think many companies are quite ready to kind of handle that scale, at least at the payment level, just because most of the payment rails used today are meant for humans. So you can imagine that the three of us, we sign up for, I don't know, XYZ APIs. We're 3 users, but the 3 of us, we can have N number of agents working for us, right? We can have a research agent, we can have a trading agent, and maybe all those agents need that same API or separate APIs. So you can see that scale kind of expanding almost exponentially, perhaps. And then we haven't even entered the realm of robotics yet, and robots will indeed themselves need an account. They need to spend for things. Maybe a robot will go and buy groceries on your behalf. So I think everything is still kind of in the early stages, and identity, that's going to be a big one too, just because it's a big gray area, and we can have a whole session on that if you really wanted. And yeah, Ty, hand it to you.
Yeah, soft shell for the Hyro identity group that meets. So if you're interested, we do talk about identity and agentic identity and decentralized identity in that group, a part of the Hyro project on the Linux Foundation Trust. Yeah, it's all of those things are important. I think that the payment infrastructure is probably really close to being done. It's just how do you integrate it into the workflows that AI agents execute? And identity is a subcomponent of trust to me. So I think trust and a lot of these protocols that are being built, like AP2, they make sense until you ask, okay, well, the vendor says that they didn't get that request in that format, and you're saying that you did, and you both just have a piece of JSON sitting on your computer. You have no way of showing who agreed on what. There's no cryptographic signature from each party. And so much different than giving a credit card in which you have the PIN and you put it into a machine and then you hit enter. There's some validation there. Merchants finding agents, agents executing payments, them agreeing on it, and then the provenance and an ability to replay when there's a dispute in that trusted execution. I kind of think it's the less flashy things are the most important, and those are the things not being paid attention to currently. So yeah, I think the hardest part is the trust layer. And I do have a very biased opinion on where you should put your metadata on a decentralized network called Hedera to have a topic ID and an attestation and a hash and a way to point to any piece of metadata an agent is sending to another agent or to a merchant to then have that reconciliation in line. So it's all very hard. I think trust is the hardest, but there's a lot of energy here. So I think we're going to figure it out pretty quickly as an industry.
I think all those points are absolutely spot on. And again, identity/trust are almost a foundation to making this whole thing work. Like you said, Ty, payments is exciting, it's flashy, it's easy to conduct, but then without the context and the foundation that legal and regulatory compliance bring, and also clarity around identity, if you don't have those aspects, then you don't have a good foundation to drive adoption at the business and massive level. So I think those are fantastic points. And I do like what you said, that you need that cryptographic audit log in case there's a dispute. You also need some sort of cryptographic agreement, or at least a way to verify cryptographically what were the terms that were agreed on when you had two agents participate in commerce. Because I think what an interesting thing about x402 is it's very easy to assure that the payment is made, but there's no strong way to guarantee that the resource server, delivered the work that was expected. And so I think that's where these other protocols and these things that we're talking about here will come into play to make this solution actually viable and more complete. All right, so a follow-up question that relates to this is great discussion on x402. How is Hedera approaching the binding of an x402 payment to the exact agent action and delivered results, so the full transaction becomes auditable end to end?
So you take it now.
Yeah, for sure. Yeah. So so if you aren't aware, we do have something called the Hedera Agent Kit, which does allow you to create your own agents the way you want, powered by Hedera. And one of the things that is there is the ability to strap your agent with the ability to write topics with HCS, which allows you the ability to kind of have that transparency audit log kind of out of the box. So you're able to do it that way. And if, say, for example, you make an agent with the agent kit that also is using a service that is compatible with x402, you can very easily log whatever you want to log in the intermediaries as in middleware on HCS. So that's off the top of my head how you go about it.
I think that's spot on, given the the highlight to AI agent, to AI Studio and the AI agent kit. I would also highlight community efforts, and as an invitation to also ask the community to participate and develop solutions for this. But one particular set of standards is what Hashgraph Online is developing. So I know HCS 14 does some work around identity, and there are other HCS protocols, I think, around the traceability of agent-agent communications. So there are efforts, from the Hashgraph side and also from the Hedera ecosystem side, and that's also a good motivation to get builders to build more of these standards and solutions. Ty, any thoughts?
Yeah, I'll just extend what Narb said as well. If you're, hey, I really need to use AP2 or I really need to use ACP, you can utilize the Hedera agent kit to then do attestations of those workflows of those subsequent protocols. So in a less nerdy way, if you're going to use Google's AP2 to do a payment with agents, if you put in a Hedera agent kit and you get that to tether in each of the pieces of metadata that your agents are using, if there were ever a dispute, you would at least have a log of what the side of your agent agreed to and signed. Best case scenario is you'd have both parties signing, but you would at least be able to start having that underpinning for very cheap comparatively to pretty much any solution out there. But yeah, I think Narbeh, you had great answers.
Absolutely. I like how you said in a less nerdy way. I think the nerdy way is very much appreciated in this forum. And then a quick plug for the general community call. If you want that less nerdy way, that's where we also cover general updates for the ecosystem and the community. So stay tuned for those. All right. Another question coming in is, can x402 be used with stable coins and crypto? So Narb, I think that one might be easy to answer.
Short answer, yes. I believe x402 is only meant to be used with cryptocurrency, so whether that's stablecoin or native gas. On the flip side, machine payments protocol works with stablecoins on the Tempo blockchain, which is Stripe's native blockchain, or Stripe itself, which gives you access to bank accounts and credit cards and whatnot. As far as I know, the last time I looked, that's the lay of the land. Again, everything changes every couple of days, every week.
Yeah.
So, yeah.
Keep me honest, Narb, but I do believe that x402 could be extended to work with fiat payments. But again, the fiat payments or the fiat rails wouldn't necessarily make sense based on the fee structures. But as long as somebody proposes a scheme, then you can determine like what's the payment rail, that you would embed as part of that scheme. But it's just that fiat doesn't make a lot of sense for a 1 cent or a 1/10 of a cent payment.
Yeah, theoretically, yes. Just because MPP is basically x402 extended, in my view. So yes, if you're someone who wants to do that, you can go do that now.
Absolutely. I do see a few comments and questions about the recording. Again, this call is being live streamed and recorded, so that will be available through multiple channels. And then the last question that I see here is, are CKPs being adopted by Hedera for A to A?
Zero knowledge proofs being adopted for A to A. Sort of it's a broad question. I think the answer, Narb, if you have any other answer, I think the answer is no. But the way that question's framed is pretty, it's like zero knowledge proofs for an agent to agent on Hedera. It's very, very specific. So A to A, agent to agent communications, in the zero knowledge proof, I'm not really sure what you would be trying to prove. Like if you're saying, hey, I have a cryptographic proof of, let's say, a carbon credit off chain or on chain, but then I have attestations of a cert, and then I need to get that validated by another agent and send a proof to them without exposing it, and then that other agent can do work on it. Presumably you could do that through a deployed EVM contract on Hedera. and have that flow. But so I guess the answer is it's totally possible to do. It's a very broad question where it's really hard to nail down exactly what the question is, but you can use A to A to send zero knowledge proofs back and forth as long as that agent has access to the validation path of whatever proof you're sending it. And that can be deployed on Hedera, but I don't think we're doing any active development in that right now.
Yeah, not that I know of. So.
Excellent. All right, friends, that's the last question that I saw. Narb, Ty, any last thoughts, any closing remarks that you would like to share with the community?
I would say get involved in the bounty. Go explore that POC code. Maybe it gives you inspiration to do something. And it's no better time to go build and explore with these technologies now.
Yeah, and I'll just jump off of what Narb said. Try to spin a dream here. There's very rare moments of technology where we have this influx of compute, where we had the internet age in the 2000s, we had the mobile revolution where you had mobile internet, Uber, pictures, Yelp in the 2010s, and now we have the agentic internet, which is this giant inflection point that even if you feel intimidated by technology or you're just getting started, the ability to get into the thick of it and right onto the bleeding edge is so high, and it's very rare. It's like once a decade. So if you're interested at all in this, absolutely take some time. We have a great bounty program right now with x402 to just kind of like get involved. There's a community of people that can help you and you can talk to. You can present something at the end of it and get some resources for yourself. But if you're interested, now's the time to dive in. You're on the same playing field as most people because we're all learning this new technology. Yeah, so jump in and always reach out. I know Ed is amazing at answering any DevRel questions in his team.
Absolutely. It's certainly a team effort. And last but not least, I do want to give a call out to our folks behind the scenes making this stream and these monthly calls run very smoothly. So awesome job, Luis and Fermin, as always. And I love the points that you guys made, you know, from the big picture and the pivotal moment that we're in to the step that you can take today. Go check out that POC and sign up for that bounty. So Narb, Ty, thank you so much for having us, guys. Awesome content as always, awesome conversations, and thank you everyone for watching. Have a great rest of the week.
Peace all. Cheers.
Thanks. Cheers.
Introducing the Hedera AI Agent Kit, the easiest way to build intelligent on-chain agents. Designed for developers, it's a modular, open-source toolkit to build, deploy, and scale trusted AI agents on Hedera, powering a more connected digital economy. With the AI Agent Kit, you can build agents integrated with industry-leading LLMs. Use industry-standard tools like LangChain, Vercel, AI SDK, Eliza OS, or MCP to build agents that do more than just talk. From concept to deployment. Agents built with the kit can create tokens through the Hedera Token Service, sign and send transactions, post to the Hedera Consensus Service, and call smart contracts, all autonomously or with human oversight. Thanks to Hedera's fixed fees, security, and fast finality, agents run with the predictability and performance needed for real-world applications. Most importantly, everything is verifiable. Each action your agent takes can be logged on-chain using Hedera Consensus Service, enabling trust, auditability, and compliance. With pre-built plugins, connecting your agents to decentralized exchanges and lending protocols is easier than ever, enabling autonomous DeFi operations out of the box. Intelligent agents, verified actions, transparent results. This is where scalable AI meets decentralized trust. What future will you build?